Are we truly alone in this vast cosmos? Consider the observable universe, a staggering expanse spanning about 90 billion light-years in diameter. Within this immense scope, we find at least 100 billion galaxies, each harboring between 100 to 1,000 billion stars. Recent discoveries have revealed that planets are not rare but plentiful, suggesting the presence of trillions of potentially habitable worlds. This proliferation of planets should offer countless opportunities for life to emerge and thrive. Yet, where is the evidence of this cosmic life? Why isn't the universe teeming with the bustling activity of alien spacecraft? Let's recalibrate our perspective. Even if extraterrestrial civilizations exist in distant galaxies, our chances of detecting them are slim to none. The relentless expansion of the universe places everything beyond our immediate galactic vicinity, the so-called local group, beyond our grasp forever. Even with hypothetically advanced spacecraft, the journey would span billions of years, traversing the most desolate regions of space. Therefore, let's narrow our focus to our own Milky Way galaxy. The Milky Way is our cosmic neighborhood, a galaxy containing up to 400 billion stars. To put that in perspective, counting each star at 1 per second would take a human 100 lifetimes. Within this stellar sea, around 20 billion stars are similar to our Sun, and estimates suggest that about a fifth of these have Earth-sized planets residing in their habitable zones, regions where conditions are ripe for life. If a mere 0.1% of these planets hosted life, we'd be looking at 1 million life-bearing worlds within our galaxy. But there's more to consider. The Milky Way is about 13 billion years old. The early days were chaotic and hostile to life, but after 1 to 2 billion years, the first habitable planets emerged. Given that Earth is only 4 billion years old, there have been countless opportunities for life to develop elsewhere. If even one of these planets had evolved into a spacefaring super-civilization, we should have noticed their presence by now. What might such a civilization look like? We can categorize them into 3 types. A Type 1 civilization can utilize all the energy available on its home planet. For reference, we humans are currently at about 0.73 on this scale and are expected to reach Type 1 status within the next few hundred years. A Type 2 civilization would be capable of harnessing the total energy output of its home star, an endeavor that sounds like science fiction but is theoretically possible. Concepts like the Dyson sphere, a massive structure surrounding a star, come to mind. A Type 3 civilization would control the energy of an entire galaxy, making them godlike in comparison to us. But why would we expect to detect such an advanced alien civilization? If we could construct generation ships sustaining populations for about 1,000 years, we could theoretically colonize the entire Milky Way in 2 million years. While that sounds lengthy, remember the vastness of our galaxy. Given millions, if not billions, of potentially life-sustaining planets and the greater time these other civilizations might have had compared to us, the question arises, where are all the aliens? This is the essence of the Fermi Paradox, a puzzle that remains unsolved, but not without intriguing hypotheses. Let's delve into the concept of filters, significant barriers that life must overcome. These filters come in varying degrees of severity. First, consider the possibility that great filters lie behind us. It might be far more challenging for complex life to develop than we currently understand. The exact mechanism for life's origin remains elusive, and the required conditions may be extraordinarily complex. Perhaps the early universe was far more hostile, and only recently have conditions become conducive for complex life to flourish. If this is the case, we might be unique, or among the first civilizations in the cosmos. Second, contemplate the notion that great filters await us in the future. This scenario is particularly daunting. Perhaps life at our level exists throughout the universe, but invariably meets destruction upon reaching a certain stage, a stage that we have yet to encounter. Imagine advanced technology that, once activated, annihilates its creators. The last words of every advanced civilization could be, "This new device will solve all our problems once I push this button." If this is true, we might be closer to the end than the beginning of human existence. Alternatively, there could be an ancient Type 3 civilization monitoring the universe, eliminating any burgeoning civilizations instantaneously. There might be truths out there better left undiscovered. We simply can't know. Lastly, we must consider the possibility that we are alone. At present, we have no evidence of life beyond Earth. The universe seems silent and lifeless. No messages are being sent our way, and no one is answering our calls. We could be entirely alone, isolated on a small wet rock in an eternal, indifferent universe. Does this thought terrify you? If so, you're experiencing the appropriate emotional response. If we allow life on Earth to perish, it might mean the extinction of life throughout the universe, forever. In this case, we must venture to the stars, striving to become the first Type 3 civilization to preserve and propagate the fragile spark of life until the universe breathes its last breath and fades into oblivion. The end of humanity may be closer than we think, and its inevitability is a sobering prospect. Why is this potential reality so dire, especially when the idea of extraterrestrial life is so exhilarating? Let's envision the development of life as a series of ascending steps. The first step involves inert chemistry organizing itself into self-replicating, stable, yet adaptable patterns. The second step requires this early life to grow more complex, constructing intricate structures and utilizing energy more efficiently. Next, these cells must combine into multicellular organisms, allowing for incredible diversity and complexity. On the subsequent step, species evolve larger brains, leading to tool use, culture, and shared knowledge, thus further increasing complexity. This species then becomes the dominant life form on its planet, altering its environment to suit its needs. At present, we find ourselves on the cusp of tentative space exploration, beginning to reach out from our planetary cradle. Given that planets have finite capacities and lifespans, any species aiming for longevity will seek new worlds to colonize. The logical progression from here is to colonize the solar system, followed by interstellar expansion. The ultimate step is becoming a galaxy-wide civilization. This progression likely holds for any advanced civilization, regardless of its origin. A species driven enough to dominate its home planet is unlikely to stop there. With up to 500 billion planets in the Milky Way, including at least 10 billion Earth-like ones, many of which are older than Earth, we should see signs of galactic civilizations. Yet we observe nothing. Space appears empty and lifeless. This suggests an obstacle preventing life from advancing beyond our current stage, a great filter. This filter is an insurmountable challenge or threat that almost all species fail to overcome. There are two possible scenarios. One, we are exceptionally rare and fortunate, having passed the filter already. Or two, the filter lies ahead of us, and our doom is nearly certain. Our fate hinges on where this great filter resides on our staircase. Is it behind us, or are we marching towards it? Scenario 1, the filter is behind us. We are the first. If the great filter lies behind us, it implies that one of the steps we've already passed is extraordinarily difficult to achieve. Which step could this be? Is life itself an exceptionally rare phenomenon? The likelihood of life emerging from inanimate matter is highly debated. Some scientists believe life emerges wherever conditions are favorable, while others suggest Earth might be the universe's sole cradle of life. Another possible candidate is the emergence of complex animal cells. A unique event marked this step, happening just once as far as we know. A primitive hunter cell engulfed another cell, but instead of consuming it, the two formed a symbiotic relationship. The larger cell provided shelter, resources, and environmental interaction, while the smaller cell used these benefits to generate additional energy for both. This symbiosis allowed the host cell to grow larger and more complex, ultimately giving rise to the diverse animal life we see today. Perhaps the Milky Way hosts countless planets teeming with bacteria, but none have achieved our level of cellular complexity. Another challenging step could be the development of intelligence. Humans often pride themselves on their cognitive abilities, from solving crossword puzzles to writing romantic novels. However, having a big brain is an evolutionary gamble. Brains are fragile, consume vast amounts of energy, and offer little advantage in a physical fight with predators. Despite these drawbacks, it took modern humans 200,000 years to progress from basic tools to advanced civilization. Intelligence might not be as advantageous as we assume, and we could simply be fortunate that it has worked out for us. Scenario 2. The filter is ahead of us. Many have already perished. If the great filter lies ahead of us, it represents an existential threat far more dangerous than anything we've faced thus far. Even a catastrophe that wipes out most of humanity or sets us back thousands of years wouldn't be the great filter. It would merely be a temporary setback. On cosmic timescales, millions of years are fleeting. To qualify as a great filter, the threat must be so devastating and insurmountable that it has obliterated most, if not all, advanced civilizations in our galaxy over billions of years. One grim hypothesis is that a species gains the capability to destroy itself as soon as it takes control of its planet. Technology could easily be the vehicle for such destruction. It must be something so universally discoverable and so perilous that its mere existence poses an existential threat. Consider the potential for a large-scale nuclear war, self-replicating nanotechnology spiraling out of control, or genetic engineering unleashing a perfect superbug. There might be an experiment that inadvertently ignites the entire atmosphere, or a super-intelligent AI that annihilates its creators, whether by accident or design. There are also dangers we can't yet foresee. Alternatively, the cause might be simpler. Species capable of dominating their planets might inevitably destroy them in the process of competing for resources. Perhaps ecosystems are susceptible to runaway chain reactions that, once initiated, cannot be stopped. In this scenario, any civilization advanced enough to alter its atmosphere's composition would make its planet uninhabitable with certainty. Let's hope this is not the case. If it is, the path to becoming a galactic civilization is fraught with peril, and our survival hinges on avoiding the same fate that has likely befallen countless others before us. If the filter lies ahead of us, our prospects are grim. This is why discovering life beyond Earth would be a terrifying revelation. The more prevalent and advanced life is in the universe, the more likely it is that a great filter awaits us. Finding bacteria would be concerning. Discovering small animals would be worse, and encountering intelligent life would be outright alarming. Stumbling upon the ruins of ancient alien civilizations would be catastrophic. The most hopeful scenario for us now is that Mars is completely lifeless. Europa's oceans are barren, and the vast expanse of the Milky Way contains only empty oceans embracing dead continents. That there are billions of empty planets waiting to be discovered and populated, billions of potential new homes awaiting our arrival. In the face of these cosmic mysteries, we must continue to explore, learn, and hope. Share your thoughts, subscribe for more intriguing content, and comment below with your perspectives. Together, let's venture into the unknown.